About polygons today, starting our unit with some information about polygons. So from the first section, it says a polygon is a closed figure formed by three or more line segments, which we call sides. And as a reminder, line segments start at a point and end at a point. So when we are looking at different polygons with different sides, we'll be calculating a lot of this information here, and I'll show you how. Starting with the sum of the interior angles. So all polygons, because they are closed figures, they have interior angles. Like on this triangle here, we have 3 angles inside of it. And we can find the sum of any polygon's interior angles. Remember, sum means total of all. So the sum of the measures of the interior angles in any polygon can be determined by the number of triangles that can be drawn within the polygon. Complete the table below and look for a pattern to find the sum of the degrees in any polygon. All right. And this is determined by the number of triangles that can be drawn within the polygon. So how many triangles can we draw? Let's start with this. How many sides are on the triangle? There are 3 sides. And how many triangles are inside the triangle? Just 1. And the sum of interior angles, well, we know all triangles' angles add up to 180. We know that each interior angle of an equilateral triangle is 60 degrees. Now your quadrilateral, this is any shape that has 4 sides. Looking at the picture, we have 2 triangles that can be drawn inside. So if each triangle has 180 degrees and we have 2 triangles, how many interior angles can we have? Do we have in total? 360. All right, pentagon. We have 3 triangles and how many sides? 1, 2, 3, 4, 5. 5 sides. So if we can draw 3 triangles inside of a pentagon and each triangle has 180 degrees, that means in total we have 540 degrees. All right, I want you to pause the video and take a few minutes to try and fill out the rest of the table here, but I will tell you this has 6 sides, 7, 8, 9, and 10. So go ahead and pause the video, see if you can figure out the rest of it based on the pattern. All right, now that you've finished the section, let's check. Inside the hexagon, which has 6 sides, we can draw 4 triangles. So in total, we have 720 degrees. On the heptagon, that is a 7-sided shape, we can draw 5, and that is a total of 900 degrees. Of course, this continues 6, 7, and 8, and then our degrees increase by 180 each time our shape adds a side. And the last one is 1440. Okay, so just some things to talk about too. Heptagon is 7 sides. Octagon, think octopus, 8 sides. Nonagon starts with 9. N starts with N, so 9. Decagon, decade, 10 years, 10 sides. Okay, next we're moving on to the interior angle sum formula. So we can find the sum of the interior angles of any polygon using this formula. It says if n represents the number of sides of a polygon, then the sum of all the interior angles, s, can be found using the formula s equals 180 parentheses times n minus 2. Remember, n being the number of sides. So let's take a look at these problems below. I actually want you to write this here on your notes. On the left side, we're going to say that any shape can be considered an n-gon, with n representing the number of sides. So here in this next section, we see 15 gon, 21 gon, 48 gon, and 36 gon. That number is just telling you it is a polygon with the definition right here. Polygon, closed figure formed by 3 or more line segments. And then it tells you that the number is how many sides. So here we have 15, n is 15, and our formula, we're going to say S equals 180 times 15 minus 2. Now you can put that in your calculator, and our total is 2,340 degrees. So if we were to take a 15-sided polygon and add up and measure all of the angles and add up all of the angle measurements together, the inside angles would total 2,340 degrees. Let's take a look at number 2. Here we have a 21 gone. So what is our n? The number of sides, or n, is 21. So we plug it into our formula. S equals 180 times 21 minus 2. Taking that into our calculator, we get 3,420 degrees. So in any 21-sided shape, all of its angles total 3,420 degrees. Go ahead and try number 3 and 4 on your own. Pause the video to do those on your own. All right, hopefully you did pause the video and you did do those problems like I asked. For this one here, for the 48 gone, you should get, oh, I didn't put it in the calculator, but hopefully you did. We should have 180 times 48 minus 2. And this one is 180 times 36 minus 2. So I'm going to check. Did you have those answered, or did you just copy what I put? Let's take a look at the next page. Now, a regular polygon. A polygon, or a regular polygon. A regular polygon is a polygon, a polygon in which all side measures are congruent. Now, what does it mean for something to be congruent? Equal, same. So because all the sides are congruent, that means, well, what do you think does that mean for our angles? If all the sides are the same measurement, the same length, what do you think that means for the angles? Over here, we're going to say, therefore, all angles are also congruent. So if we have a regular polygon, which means all the sides are the same, then we know that all of the angles inside are also the same. It says here, the measure of a single interior angle in a regular polygon can be found by dividing the sum of the interior angle measures, S, by the number of sides, N. So we can find a single interior angle measurement by using this formula here. S equals 180 times n minus 2, all divided by n. This is our interior angle of our single interior angle of a regular polygon formula. Okay, it says find the measure of each interior angle in the following polygon. So let's look at number 5. It's a regular pentagon. So look back at your page from before. I'll give you a second to do that. How many sides are on a pentagon? Hopefully you looked, and there are 5 sides on a regular pentagon. So we're going to use that 5 as our n and plug it into the formula we just wrote at the top. S equals 180 times 5 minus 2 all over 5, our n. And you could put this whole thing in the calculator, and when we do that, we get 108 degrees. So one pentagon's angle is 108 degrees. All right, go ahead and try number 6. I'll give you time to do that. Okay, so here you had a regular 18gon. So how many sides are in an 18gon? If you guessed 18, then you are a genius. So let's plug it into our formula. We get S equals 180 times 18 minus 2 all over 18. And you can put that whole thing in the calculator. And I don't have a calculator near me, so hopefully you got the answer there. And I will make sure you have an answer there tomorrow so I know you actually did it. All right, next section talks about sum of the exterior angles. So all we've talked about so far is interior angles. Now we're moving on to exterior angles. Now what does that mean? Exterior angles are supplementary to their adjacent interior angle. What does it mean to be supplementary? Do we remember? I think I shared with you a funny catchphrase or like saying that one of my teacher friends used to say, and she would ask her kids, "What's sup?" But it sounds like "What's up?" So "What's up?" And they would say 180, so they could remember that supplementary angles are 180 degrees. So supplementary means they add up to 180. So the exterior angles are supplementary to their adjacent interior angle. Find the measure of each exterior angle on the polygons below, then give the sum of all exterior angle measures. Okay, so as you can see on this first triangle and on these other shapes here, if we continue the shape's line, segment, and actually make it into a ray where it starts at one point and goes off into another direction with an arrow, remember that's a ray, ray. Yeah, let's recap. This is a segment and something with arrows on the end. This is a line. So if we create a ray coming off of the ends of each side of our polygon, then we have created exterior angles, and exterior means outside. So we are looking for the outside measures created with the interior angles. As you can tell, they create a straight line, the two of them. So the two of them together create 180 degree straight line, or they are supplementary. So if the whole thing is 180, how can we find this missing angle? We can say 180 minus 61, and that's going to give us 119. So this one is 119. This next one here, 180 minus 79, and we get 101 degrees. And this last one, 180 minus 40, and we get 140 degrees. So now for this little box right here, it says the sum of the exterior angles measures. So we're going to take 101, 140, and the 119 and add them together, and we get 360. Interesting. Okay. I want you to try the next three on your own: quadrilateral, pentagon, and hexagon. I'm going to give you a few seconds to pause the video and try these on your own. Pause the video. Okay, hopefully you subtracted them from 180 already, and you found that these angles are 56 degrees, 104 degrees, 91 degrees, and 109. These four total up to 360. On the pentagon, we have 82, 59, 93, and 50. Oh, one more, and 76. All of these, oddly enough, also total to 360. And for the last one, surprise, surprise, they add up to 360, and these are 51, 56, 68, 57, 63, ooh, and the last one, 65. That was a lot there. All right. So what we've learned from this section, what can you conclude about the sum of the exterior angle measures of a polygon? If you're thinking that the sum of the exterior angles of any polygon is always 360, then you are correct. The sum of the exterior angles in any polygon equals 360 degrees. All right, let's take a look down here. Some more examples. We're almost done for today's notes. Number 7 says, what is the measure of each exterior angle of a regular hexagon? Let's focus on some of these problems because some of them say regular and some of them do not. Oh, I guess all of these do. But let's remember, what does it mean for a polygon to be regular? Regular means that all of the sides are the same length, all of the interior angles are the same length, which means all of the exterior angles are the same length too. Sides, oh, not two S's, sides congruent, angles congruent, and this is interior angles, and exterior angles congruent. So regular means that all of its parts are congruent. So what is the measure of each exterior angle of a regular hexagon? Okay, look back at your first page. How many sides are in a hexagon? If you're thinking 6, then that is correct, and 6 will be our n. Now they want to know the exterior angles. Oh, I forgot to write the formula. Our formula for finding the measure of each exterior angle is going to be E for exterior equals 360 divided by n, which again, n represents the number of sides. So using this formula, we will say E equals 360 divided by n, which is 6. And we get 60 degrees. So in any regular hexagon, the exterior angles are each 60 degrees. Let's take a look at number 9. Or actually, try number 8 on your own really quick. Number 8, try that one on your own. I'll give you a minute. Sorry about the bell. Would you guys be awesome and put all the calculators away? Thank you. And then just make sure the Chromebooks are charging. That would save me a lot of time. Sorry, guys. Okay. Hopefully you finished this problem already. It's not that hard. We take 360 and divide it by our number of sides, which was 24. And when we do that, we get 15 degrees. So hopefully you got that one right. Let's take a look at number 9. If the exterior angle of a regular polygon measures 12, how many sides does the polygon have? So this time we're using the same formula, but we're using it backwards. So we're actually going to look for the number of sides. We're looking for n, and they're giving us the e, the exterior angle. So plugging into our formula, we could say 12 equals 360 over n. And if that's confusing, let's clear this up. How many sides? We're looking for sides, and we said multiple times that n represents the side. So we're looking for n. It tells us that the exterior angle is 12. And that's what we solved for on the last problem here. So we were solving for E. So E is the exterior angle. Solving for N, just like we did with inverse trig, we need to multiply by N. and then divide by 12 on both sides so that the n is by itself. So we need to say n equals 360 over 12. Put that in your calculator, and we get 30. So this means we are dealing with a 30gon, so a shape, a polygon that has 30 sides. Go ahead and try number 10 on your own. All right, let's check your work. It's saying the exterior angle is 40 degrees. How many sides? So again, we're looking for n. So plugging in 40 for E, 360 divided by n. We multiply by n, ooh, not m. We multiply by n. And then on the next step, we're going to divide by 40. I would prefer to put the 40 in front, but 360, then divide by 40. And we get n equals 9. So this is a 9gon, or a polygon with 9 sides. All right, that concludes our notes for today. Please let me know if you have any questions. Tomorrow we will continue with this page. And this page, page 4, and well, all of page 4 is basically going to be work on your own. So if you still have time, I would suggest trying to work through page 4. Well, never mind. Hopefully I can cut this part of the video off. But if not, ignore what I just said. We're going to end right here on page 3, and I will see you on Friday.